Right, guys. First time we got a projector to work, which is nice. And it turns out there was a HDMI cables issue, the adapter issue. A new one from Amazon starts working. So we'll talk about some of the details of this tutorial 3 on the website. I'm pretty sure it's going to be helpful. It's not a waste of time. It's going to save a lot of your time. So first, the goal here is to stream video to your phone or a browser on a computer. And ESP32 cam is going to work within one local network. So if you connect it to the Wi-Fi of the college and your phone to the college as well, it should be able to receive the video streamed to the little GUI open up in the browser. Okay, and it serves as a server. So ESP32 serves as a server on the local network. So if you type the IP address in the browser, it's going to show the web page. So if you have a web page, the browser opening up the web page, it has to be HTML, right? So guys have been doing HTML with Composer a lot. It's a good place to start with learning what's going on in there. And so we'll talk about the sensors first and what we have to put on the board. And then I'm going to let you know where should you modify the HDMI to rotate the image in the browser later, okay? So the first sensor you need to use is called BMP 180. It measures altitude and temperature as well. It must be able to do something else, but we are not using them. So make a simple connection. I believe it's, so what's the protocol here? Yes, I2C, right? It's ICL and SDA. And definitely your ESP32 has that port available for it. So make the connections, definitely use the rod antenna and power it up using an individual power supply. Do not use the USB, which is not able to provide good amount of current for it. It's a Wi-Fi communication, especially streaming video, takes a lot of current. And I have to make some of the changes. I think it's simply just a typo from the example code. The altitude is definitely not a percentage, right? You have to change it to meter. And if you measure it, if it's functioning, you can see it's room temperature in the building, pretty much. And I think I did it in my house. So it's 26.7 degrees.
What is that?
Altitude is a meter.
Oh, meter.
Yeah, it's about 2,000 meters in Durango, which is pretty accurate. So I did a search online in Google. See? Elevation of Durango, which is 6,500 feet, right? Which is about 2,000 meters. And you can see, this is Sky Ridge. It's very similar to the Durango's average elevation. That's the first one you need to do in the week. And then, so this snapshot is from an online tutorial, okay? And I believe I have a link here, so you can refer to that tutorial for more details. But we made it in a way that we use all the components available in the lab. So for example, we're not using the switch like this, and we use a different motor driver, but all the other things are very similar. So I already put the box of this driver, the drivers like this in the lab on the bench. I can find the part components over there, and headers, the board. That's how you plug it into the prototype PCB.
What's the difference between that motor driver and like that?
They are both motor drivers. I believe they are both H bridges.
Yeah.
Different efficiency or different design, or different current readings, or different voltage readings, right? But you can tell that this one is definitely will be able to handle higher power because it has a heat sink on it. It looks bigger usually, which can handle more current and power. Yeah, this guy only has a little IC on it. So you can look into the details in the data sheet and see what's the current rating. If you're driving a small motor like this, it's probably fine to use either one. But if it's doing a bigger, like a stepper motor, drains more current, you may want to use this one instead. Okay, that's what I did in the lab. Okay, this was my current board. The connections. So this is the driver we're going to use. See, it's also H-bridge.
Yeah.
Okay. No, it's a 12 volts from the power. So you have to use 3. So 3.7 volts per LiPo battery cell. So you need to use 3 of them, I believe. But I think, how many did I put in here? I don't know. But eventually you are able to stream a video, camera, and I'll show the issues and what was done and what was not done. So it is controlled by a phone, right? So have push button on the phone, connect to the Wi-Fi, and you can stream the videos to the phone and move the car. So it's pretty much a prototype of a robot game, a robot toy. And you can basically sell it, right? If you make it a better product. Modify the PCB and all the things. But if I probably have noticed that the video on the phone, if you place the ESP32 vertically, and the screen or whatever the video is 90 degree off from the upright one.
I found that I've used different ones with different. You just put them on camera.
Really?
Yeah, one of them had like the sideways like that, and then one of them was like more vertical.
Oh, is that because of different?
Default, not like software.
No, it's a different piece of code probably, and because this is different script being used. Definitely, yeah, that's one of the tasks, right? So you can look into the images or the script in your previous task, which shows the upright version, right? And you can find out that piece of code and put in here to rotate it. I'm going to show you one of the options. So if you open up the code here, you can see. So this is an example from the textbook, and I just want to show you where is that piece of code is. So right after the pin assignment, okay, and you scroll down to the HTML's head. Wait. Here, right, above body, you'll see an image. So that image is the window for the video, I believe. So you can see it's 100% of the maximum width, height, auto, and you can start a new line and rotate it. So this is your job to find out the command to how to rotate. I believe it's something rotate 90 degrees, right? It's a simple command to put in there. So this is something you can search in Google. For example, how to rotate an image in HTML. Pretty simple. And this should be the place that you plug in that code in here. Okay, that's the first thing you should do. And the second, if you watch the video, you can find out the car is not moving really smoothly, right? Once I push the button, it just start moving right away. See? It's just too fast. So what I'm trying to let you guys to do is when you push the button, so the car slowly accelerating itself instead of start right away. You push it, it's and then getting faster and faster. So it's just a delay you are adding to the movement of the motors. And if you look into the code here, you can see that they are. So the code for motor spinning the motor is over here, right? The motor pin, whatever, writing 1 zeros. So it's pretty much this part of the code. And How could you add a delay to it?
Like set a function.
Yeah, just add a loop or something, make it counting down, or just add a delay to it. But it won't be a simple delay function. Just got to be creative. How do you delay it? When you push it, it gets into this function, and it shouldn't, because the microcontroller, whenever it runs all the code, it runs at 60 megahertz. If it's Arduino, if you have 32, it's higher, even higher speed. So it executes all the code really quickly with the clock frequency, right? So which means if it runs the digital right, it's gonna apply that voltage to the motor and spin it. How can you delay it? For example, you push it, you add a for loop and count it down, right? Add a constant to it, to the counter, and count it down until which number, then start moving things. Debounce, you don't have debounce because it's not a mechanical button. It's a screen smartphone button. You don't have to debounce it. No, you're not debouncing it because it's should be a lot of ways to do it. Okay, that's the second thing you have to modify. And a lot of soldering. And you need this power supply. And so for building this prototype, we're not directly building a power supply again. So I'm going to give you that adjustable power supply. So you have to work probably together, for two of you work together. One is adjusting the resistance of this one in order to give a 5 volts output. The adjustable ones are not giving 5 volts at the very beginning. They are a fresh product from the manufacturer. So you have to use a screwdriver to change the resistance here until you receive 5 volts before you can use it. So one person is spinning that little screw, and another one probing these 2 voltages. I don't think it's giving 12 volts. The input can be 12 volts, but stabilize it at 5 volts. Yeah. But that reminds me about the 12 volts. If I'm looking at my battery, I couldn't really tell if I use 2 cells or 1 cell. So you saw a 12 volt label on the driver, right? But you definitely don't have to use that 12 volts. I think what I used are just totally 5 volts. I didn't even use that 12 volts. Because this guy is providing, the 2 cells are providing 7.4 volts. It's going to work. Just won't be as powerful as 12 volts. But because looking at this cartridge, it's definitely 2 cell battery. The big blue LiPo batteries I have in the lab. So each one is 0.7 volts. It's giving 7.4 volts. So I'm not using 12 volts at all. Okay. And yeah, I have to solve the acceleration issue, which is the one I just mentioned. And also you have to rotate the image by 9 degrees. As the 2 tasks that I didn't give an answer in the tutorial. But all the rest should be straightforward. Just practice soldering, wiring, and not really coding because it's given. Okay, should be pretty fun because it's like building a product. Any questions on this? And next week, we're going to work on the PCB design, so there won't be a lecture. So it's going to be Tuesday, Thursday, just working on the PCB design. And the power supply part, if it's 5 volts, you can copy and paste it from microcontrollers. It's a 3 amp power supply, right? You can directly use that one on the PCB. So what you expect on the PCB? Let's look at the circuit here.
Give me some.
Okay, so first, we are not remaking this power. Okay, just plug it in to your board, leave ports there and plug it in. It's a power module, we're not reusing, you're reusing it. Actually, for this low power motors, we really don't have to use this. You know, we can just use the ones we did in circuit one. It's a very simple LD293 that motor. Have you used that one in the past? Actually, this can be a good chance for me to get a PCB out of it so I can sell it in the future. I don't want to buy these modules. Let me show you. They are, yeah. So, because I'm recording so you can find the link later on, right? So if I, let's see, if I go to teaching, what are the tool labs? So this chip, have you used this chip in the past?
Robot car.
Huh?
Circuit one robot car.
Yeah, circuit one robot car. Have you used it? This one? It's just a very simple dip motor driver, and it works for the same car actually. It's a good toy to sell, I believe, in the future. Okay, let's come back here and see what is the realistic plan for this PCB. Because you have this week and next week, right? You have 2 weeks. It's a lot of time to work on it. So, and it's extremely simple to get that PCB done. Okay, so if you look at this driver, it has pins. So in that case, should we still use this driver at the very beginning? It seems like a waste of time if we have to switch to the cheaper one.
Oh, I looked it up too. The only difference, the only difference is this one supplies 2 amps max.
Yeah.
The 293D is only 600 milliamps, but that's been more than enough to drive those motors.
Yeah, that's right. So I have another link. I blocked it, but I will bring it back to the website, and I'm going to send you the link. So let's do that. Let's use that driver. It's going to be the very similar connections. The one I showed you. Okay, use that driver. So do not use this driver at all. Let's use that driver to get the car to move. And so this is the entire circuit. The power supply module, you did it in microcontrollers. So we directly use copy and paste, no problem on that. And the motor's connection to the driver is just the 2 wires connect to the driver's points. It's the same as the cheaper one. So just do the connection, it's very simple. So for digital control, I believe these 4 pins is something you have to look at because they are associated with the code. If you open up the code, see how they drive these pins. You may or may not have to change that code in order to drive the cheaper driver. They should be able to operate in a similar mechanism, I think, because they are both H bridges. That's it. That's the power. So the only things you have to change, have to think about or consider is the 4 pins. and the 4 digital pins. And I believe the 4 digital pins are being written like 1010 that way. Forward, so turn on, off to provide that motor 1, motor 2. So 2 motors. So each motor on one motor on one. Okay, yeah. So because each motor you need the motor driver has 2 pins to define the direction of the motor's rotation. If you give a 10, it rotates that way. If you give 01, it rotates the other way. You know what I mean? There are 2 pins on the driver. That's why it is like you have to assign a 10 to the 2 pins for motor 1. So it's motor 1 underscore pin 1, or motor 1 underscore pin 2, because there are 2 pins to define the direction of the rotation of the motor. All right. So when you want to move the motor the car forward, right? So do a 10 and 10. It's like a control logic, like control code for the rotation of the motor. So this works exactly as a cheaper motor driver. Good news. You don't have to really modify too much. If you are seeing the motor, if you directly do the connection and upload the code to the microcontroller, but eventually the motors are driving this way instead of this. So it's turning, turning like this instead of moving forward. What do you have to change? Swap the wires of the motor. Right? For example, since you didn't know which one should be here, which one should be here, right? And just randomly you connect the 2 motors connections to the driver. It's okay, and then you upload the code, right? And you find out it's moving like this or this. Okay? If it moves like this, for example, this is front, okay? If it moves like this and you want to move it forward, what should you do? Change the connection, just swap the 2 connections. That's it. So it's able to do this, all right? So do a really quick testing, maybe just to use one block of the code and see if that works. If you make it work, it should work for the left and right turn and backward as well. Make sense? Okay, so what if you are moving forward, but they both rotate like this? You have to swap both of them, right? Oh, change the code, yes. That's right. How do you change the code? How do you change the code, Connor? No, that's and you have to change the button's name as well. They are just the strings. Yeah, you could do that. What are the pieces here? You just swap 1 and 0s, right? Okay, so the goal here is to make a affordable toy. So we're going to use a cheaper driver, and this one will be plugged in. How do you design it? How do you plug in this one? Because these are the pin headers, right? What the product looks like eventually. Definitely one PCB, okay? And have your power regulators, right? What else do we need? Motor driver, right? Motor driver. Battery. Yeah, come on, just put that in, right?
how to want to mount this one. It has to be upright. The camera has to face front. You only have two headers here, right? Yeah. So two headers, you can solder two headers, have one with card and place the solder or you mount it. You can use this manually brackets. So you have to use the holes here for mounting. Two is how to mount it. Two is 3 or 4. This should be fine. Did you see these mounting brackets? Have you seen them somewhere? Hmm? Yeah, I think 2 will be fine. Yeah. 2 mounting brackets. There's a drill hole on the car. You know the 90-degree mounting brackets? So like a block in front of you. I guess, do you know what I'm talking about? Yeah, it's an album. Yeah. I don't know. The smaller ones are the round trip ones like this. It's like the long ones. You need the long ones, just the small ones like this. Any other ways to mount it? If it's just the 10-year-old kids who don't know how to use well.
I was thinking. No.
Yeah, great idea.
Stop.
So mount the PCB to the yeah. But they have to drill holes.
But you have 2 holes towards the side that place flat. I'm all points that the solder to string it together, just solder the pads that on
That's right. So have another PCB.
well, it would just be one single PCB, so one or 2, but it wouldn't design to make it break apart and solder together.
Break and solder.
So you design it all like that. So you put the parts together, break it apart. You have the holes.
That's what you did. Solid.
Isn't that cool? For a long time, thinking something like that.
And then we don't have matter here as well, so we solder it. But we didn't have matter, right? So we didn't.
Well, I think it's the first iteration. I hit it too long.
Did you see it? So it has metal pads.
Oh,
And you have metal pads here, so you solder it, it's gonna seal it.
yeah. I was wondering about these pads.
You know what I mean?
Oh, pretty cool. Show me.
Yeah.
I want to see it.
It's sick. It's awesome.
Oh, it works.
Do you just actually snap it off work?
Yeah, you can snap it. You can try to snap it.
No, I don't want to.
Do it. So that one.
So where do
It
you?
doesn't work. So it's just garbage.
Just at the bottom, you add metal pads on both pieces, right?
So you can.
So you can solder it at the bottom. And the bottom PCB.
That is cool.
Approval from Congress.
Just well, you already showed us, but I know Greg was trying to explain it to me. Think of how. Well, that's engineering.
Yeah, we should do it.
I think that would be that.
That's a good
Try
solution.
that.
Yeah.
A 10-year-old can do that.
Can do that, definitely. You can or you don't have to solder. If they don't have solder, if you want it's really stable, reliable connection. Solder. Or glue it. And the bottom part would be you just design some hole on it. they just drill hole in the car, put the car, maybe 4 holes, 4 corners. Yeah, I believe we should do this. I don't want to waste time to get another project that I will never use it. The college pays me such a low salary, I should really leverage the resource to make some money in the future. Only benefit is I don't have to show up for a few hours.
It seems like a pretty big benefit. 2 hours here, 2 hours there. Go home, hang out with Chica for an hour.
Oh, that's the best time of the whole day.
I don't enjoy that, but I enjoy that.
Curious. Need to make a petting robot PCB.
Your office hours.
Oh, but we can hook it up to a security camera so he can control the petting. We could get like a little haptic glove so it determines where your hand is and then moves the robot hand.
Oh,
Then we can stream it with an ESP32 cam.
We gotta get Ryan on this. Ryan did the
Senior
robot.
Sam, we did it. The dog petter. You
That's
can
right,
pet people from anywhere.
That's great, but we do need that hand to pick up tools as well.
That is true. That is true. That's the big
So we
one.
will put it on this little robot. You can go around and.
Yeah, okay, we could write our machine learning algorithm that scans your house for piles of poop and then has a drone, it launches a drone when it identifies poop. And the drone then goes and picks it up and then like sky cranes it out of your house into the garbage.
Into the neighbor.
And
Into the neighbor's yard.
It's better have a tank of detergent, so spray that water or liquid to the carpet and clean and wash it.
That's true, that's true. And then we can make a catapult too, so it puts it in the catapult, and then we can aim the catapult at whichever neighbor we don't like the most that week.
Sounds like a crime.
It's only a crime if you get caught, Dr. Lee.
Uh-huh.
Just standing outside the door.
It's
just
bio-
watching it all goes down. Just
Watching the drone deliver the poop into the catapult.
You know it has E. coli in it, so it's considered as a biohazard.
That's chemical warfare.
Yeah.
It's not on my property anymore.
Is that clear on all the tasks?
Yeah.
So do we need to design a power supply module, a power supply circuit? For the PCB for next week? Do we need a 3-amp power supply module on it, regulator on it by ourselves? Yes, you do. You need to duplicate the one you did in microcontrollers, okay? And do you need this motor driver for the breadboard for this week? No, you are going to use a cheaper one to be consistent, so you don't have to waste time to, switch all the motor drivers. So you use the cheaper one this week and the cheaper one for the real PCB for the real product. And what else? Definitely 2 battery cells. One is a prototype deal, because you have to test something to make sure it's working before you put everything on the PCB, right? Have you done PCB, Jesse? I'll give you half a week more probably. That works. It's gonna take another week to go through the tutorials. It'll be rough. Okay. So, but wiring things on the car is fine. So you guys are on the same level. Wired it up on the car. Demonstrated this week. This is due next Tuesday. And from next Tuesday, we'll work on the PCB. I'll give you more time to work on that. But for the rest of you, should get everything done. Let the schedule here. Okay, so it's 26 for the PCB. Gerber files. And I'll fabricate it for you guys, and we'll find a time to solder and test it. Right?
Then what's next, actually?
Oh, there are a lot of things to work on. There are a lot of other things to work on.
bring the drone back. Don't bring the drone. Well, we could bring the drone.
That was year one.
Which one? The drone?
Summer fellowship.
Yeah, Ian's drone. That was horrible.
Oh yeah, that's a bit too much for a credit class. If we just do the drone, it's gonna be the whole semester probably.
That'd be sick. You can pick up your poop. I mean,
What about an automated catapult? Can we work on that next? We can
Which
do
one?
facial recognition. I could write a machine learning algorithm to detect who we don't like, and then we can launch a catapult at them. We could set it up in the CE dungeon, so when anybody comes in that's not in the CE program, they get catapulted.
Flashlights.
Yeah, the strobe light starts going off.